Okey, Assalamualaikum warahmatullahi taala wabarakatuh. Salam sejahtera semua. Okey, so hari ni saya nak sambung chapter kita yang ke-7, chapter yang baru, iaitu berkaitan dengan Maintenance Management of Building Operation System. So dia berkaitan dengan building operation Okey. So harap awak boleh follow video rekod ni sehingga habis, kerana dalam presentation saya ni saya akan selitkan beberapa hint. Okey, hint untuk test pada 24 hari bulan nanti. Okey. So pay attention with all the information that I will given in this slide. Okay, especially for the test lah. Okay, and at the same time pay attention for this new chapter also lah. Okay. Okay, content untuk slide ini saya akan cover 3 building operation system, iaitu pertama transportation, kedua processing dan ketiga automation. Okay. So untuk transportation saya akan cover berkenaan dengan elevator, escalator, moving walkways, travelator, okay, and parking system. Okay, parking system is under the automation also, parking system di mana automatic parking. Okay, tapi untuk transportation saya highlight berkenaan dengan elevator and also the escalator lah. Escalator, moving walkways and travelators. Okay, first we take a look about the elevator first. Okay, elevator saya akan sentuh berkenaan dengan overview of the type of elevators, and then elevator components and descriptions, code compliance for elevators, maintenance and safety inspection, and then the best practices in elevator maintenance, and next I will touch about the escalators. Okay. Semua tahu elevator yang seperti kita gunakan, kita panggil sebagai lift. Itu sebagai lift tu, itulah dia elevator. So actually elevator ada types of elevator. Generally two categories or two types of elevators. The first one is traction types or electric, and the second one hydraulic types. Okay. So these systems are distinguished primarily by their hoisting mechanism. Okay, hoisting mechanism is either traction or hydraulic. For the traction types, virtually limitless rise, high and medium rise, high speed but high installation cost. So installation cost tinggi untuk traction type. Tapi untuk hydraulic, dia limited to height of about 6 stories. Okay, so untuk traction dia boleh lebih daripada 6 stories. Okay, tapi untuk hydraulic just limit up to 6 stories. And then lower speed compared to traction. Traction ni dia lebih kepada dia gunakan bag lah. Gunakan bag ataupun rope untuk control the movement. So hydraulic, the hydraulic menggunakan kaedah mampatan of the liquid lah. Okay, the compression of the liquid. So that is definition of hydraulic system. Okay. So for the hydraulic, lower initial cost but higher power consumption. Okay, dia ada advantage tapi at the same time dia ada disadvantage. So the main difference between traction and hydraulic is about first installation cost, and then the limit of the high rise. Okay, di mana traction lebih sesuai untuk bangunan yang tinggi, lebih daripada 60 kaki ataupun 6 tingkat. Tapi untuk hydraulic, dia limit boleh sehingga 6 tingkat sahaja, disebabkan oleh dia memerlukan high power consumption lah. Okay, so traction ataupun electric types, under the traction dia sama ada menggunakan geared traction ataupun gearless traction. Okay, for the geared traction, a drive shaft is connected to the shift by gear in a gearbox. Nama pun gear, so dia akan ada gearbox. So bila kita dah pernah ambil tahu berkenaan dengan gear kan, awak pun mungkin dah belajar berkenaan dengan gear sebelum ni. So the rotation of the gear will affect the mechanism of the rotation itself, sama ada high speed or lower speed. Okay, so gear traction ni ataupun bila dia ada gear, dia ada gearbox, actually dia control the speed of the elevator cab. Okay, the control dia punya speed lah melalui mechanism of gearing. Okay, untuk gear traction, dia punya design operated is in the range of 100 to 500 feet per minute FPM, and restrict their use to medium rise buildings. So dia punya range of the operation is on dia punya speed range 100 to 500 feet per minute. Okay, for the gearless traction, kalau gearless maksudnya dia tak menggunakan gear lah. Okay, dia designed to operate in the range of 350 to 1200 feet per minute. So dia punya speed dia lebih berbanding dengan geared traction, and typically installed in high-rise building. Okay, so kesimpulannya for gear and gearless traction, so the difference between them is in terms of the speed range and also the application, either for the medium rise building or the high rise building, which are for the gear traction is more suitable to use for the medium rise building. Okay, for the gearless, more suitable to install in the high rise building. Okay, for this one is hydraulic type. Untuk hydraulic type dia ada 3 lagi dia punya division dia. The first one is the whole hydraulic, the second one is the holeless hydraulic, and the third one is the rope hydraulic. Okay, the first one, the whole hydraulic in ground cylinder extend to a depth equal to the rise of the elevator cab. Okay, kalau kita lihat dalam gambar rajah tersebut nombor 1 ni, di mana kedudukan whole hydraulic ni adalah di bahagian the bottom part in ground cylinder. Ini yang dipanggil sebagai whole hydraulic. Okay, di mana dia extend to a depth equal to the rise of the elevator cab. Current codes require double bottom cylinders with leak detection and containment. This is the code conduct sekarang lah, yang di mana dia memerlukan the mechanism to detect of the leak and the containment lah of the hydraulic liquid tu, hydraulic oil. The second one is the holeless hydraulic. The holeless hydraulic elevator use a telescopic hydraulic piston. Dia menggunakan piston as the driving machine, eliminating the need for an in-ground cylinder, di mana holeless hydraulic dia tak ada in-ground cylinder macam gambar rajah 2 ni. Instead of dia menggunakan cylinder piston. Okay, and currently limited to a height of about 3 stories. Okay, how about the rope hydraulic? Rope hydraulic is a rope hoseless hydraulic elevator. So means dia still menggunakan cylinder, but at the same time dia ada mechanism of the rope. Okay, use a telescopic hydraulic piston also, and the hoist rope and pulley system. Okay, so dalam holeless dan rope, dalam hole dia tak ada silinder, dia tak ada gunakan rope ataupun pulley system. Tapi untuk holeless dia tak ada silinder, in-ground cylinder, tetapi dia menggunakan piston. Untuk rope hydraulic, dia tak ada in-ground cylinder, dia ada hydraulic piston, and at the same time dia ada hose rope and pulley system. Bila dia menggunakan rope, ada menggunakan pulley lah. Okay, so that is the way how to differentiate between this category of hydraulic type lah. Okay, and then the major components for the elevators. Okay, yang ini awak boleh take note about the major components for the elevators, di mana dalam elevators ni dia ada banyak komponen. Okey. Dalam elevators komponen dia ada machine room, dia ada cabs. Cabs ni yang bawa passenger, and then horseway ataupun pits. Okay, machine room for traction elevators. Okay, traction elevators type generally located directly above the horseway. Okay, but for the hydraulic elevator type, the machine room typically located at the basement of the lowest level adjacent to the horseway. So means dalam gambar rajah yang ditunjukkan di sini, ini adalah contoh untuk traction elevator type, di mana dia punya machine roomnya berada di atas. Okay, untuk hydraulic elevator, dia punya machine roomnya berada di bawah. Okay, macam ni. Okay, ini contoh hydraulic elevator punya machine room, di mana hydraulic tank dia berada di bawah lah. Okay, and then hoist machine. Dalam major component of the elevator, di bahagian machine room dia ada hoist machine. Okay, can be geared traction machine in which the power from the motor is transmitted to the drive shaft through reduction gears. So dia ada motor kat sini, then the coupling into the hoist machine through the gear lah. Okay, reduction gears or gearless, sama ada gear ataupun gearless machine in which the hoist ropes pass over a traction drive shaft which is an integral part of the armature. Okay, daripada motor transmit the power from the motor to the dia panggil sebagai drive shaft, di mana melalui gear ataupun gearless, dan daripada drive shaft ni dia akan contact dengan rope. Okay, the groove wheel of the traction type hoisting machine over which the hoist rope pass and by which motion is imparted to the car and counterweight by the hoist rope. Okay, dia akan counter the weight of the cab by using the wheel lah. Okay, groove wheel ni adalah laluan untuk rope ni. Okay, dia ada groove. Dia punya wheel tu ada dia punya groove untuk traction of the rope lah. Okay. So this one is the hoist motor in the machine room, also called drive machine and used for traction elevators. They are the power unit that apply the energy to the hoist machine, and this motor can be either AC type motor or DC type motor. Okay, and then generator. Okay, as we know, the generator are the electromechanical device that convert mechanical to electrical lah. And then still under the machine room, governor. Okay, this governor play the role to control the speed of the cab. Okay, mechanical speed control mechanism. Okay, usually a wire rope driven centrifugal device used to stop and hold the movement of its driving rope. Basically, rope ni dia akan attach kepada cab, dan cab basically cab punya weight akan berubah mengikut bilangan passenger. Okay, kalau kita perasan, bila setiap kali every time kita menggunakan elevator, walaupun elevator tersebut kurang passenger ataupun ramai passenger, kita dapat rasakan speed dia sama, tetap sama. Okay, that speed is actually controlled by the governor mechanical system. Okay, that is the purpose of the governor lah, governor system. And then controller. This controller is a device or group of devices which serve to control in a predetermined manner the flow selection, drive speed, car selection and general operation of the elevators. So everything will be controlled by this device. Okay, dia akan control the sensors, okay, control the speed, and okay, control the selection of the cab, selection of the floor. Everything is controlled by this device. Okay, disconnect. This is a switch lah, switch to disconnect the power to the controller and cab light and located in the machine room. Okay, so di dalam machine room ada switch disconnection, ada controller, ada governor, ada generator, motor, hoist machine. Okay, so itu di dalam machine room. Okay, sekarang kita lihat apa yang komponen yang ada di bahagian hoistway. Okay, untuk hoistway dia ada roller guide. Okay, this roller guide made by steel T-section which machine guiding surfaces installed vertically in a hoistway to guide. Okay, the main purpose is to guide and direct the course of the travel of an elevator cab. Okay, dia akan menyediakan prepared for the guide rail lah. Okay, the guide rail for the elevator to travel from one floor to another floor. And then the counterweight. Counterweight is the weight that counterbalance the weight of an elevator car plus approximately 40% of the capacity load. Okay. Benda ni dia akan counter the weight of the elevator cab lah. Elevator cab basically the weight is fluctuate depending on the number of the passenger use. Okay. So makin ramai passenger yang menggunakan, makin berat. So this counterweight will be take part lah untuk counter to balance the weight lah. And then door interlocks. Okay, an electromechanical device that prevent operation of an elevator unless the hoistway door are in the closed and locked position. Benda ni yang akan detect sama ada pintu cab tersebut dah safely closed and locked or not. Otherwise, sistem door interlock ni dia tak akan membenarkan elevator cab tersebut bergerak. Dia akan control, iaitu dia kata prevent the operation. So melainkan door dan juga hoistway in lock position. Okay. And at the same time prevent opening of the hoistway door from the landing side unless the elevator is in the landing zone. So ketika bergerak juga dia akan prevent from the door, prevent the opening of the hoistway door. Dia akan prevent daripada ketika bergerak, dia akan prevent daripada door, pintu tersebut terbuka. Melainkan apabila apabila elevator cab tu tiba di landing zone. Okay. Okay, top of car station. Ini di bahagian hoistway ataupun pits. Okay, ini top of car station, di mana di sini terdapatnya control on the top of the car, di mana basically used by an elevator maintenance contractor to operate the car at inspection speed. Okay, the speed of during inspection and during the normal operation is different lah, maksudnya kat sini. So during the maintenance, the contractor will be operate the car with the inspection speed, and this can be controlled from the top of the car station lah. Okay. And then buffer ni dia can be either spring types or hydraulic types ataupun dipanggil sebagai oil buffer. Tujuan dia adalah untuk absorb, okay, descending car beyond its normal limit of travel by storing or by absorbing and dissipating the kinetic energy of the car. Basically ketika dia elevator car tu turun sehingga the maximum limit, okay, mungkin masa turun tu laju sikit lah. So ketika menurun tu wujudnya kinetic energy lah. So buffers ni akan bertindak untuk absorb or dissipating the kinetic energy. Okay. And then the spring buffer type used for elevator with speed less than 200 feet per meter. Okay. While for the oil buffer is for the speed greater than 200 lah. Okay, depending on the application, either 200, less than 200 speed or more than 200 speed. So kalau more than 200 speed, dia lebih kita akan gunakan oil buffer. Okay, so di bahagian hoistway ada buffer, top of car station, door interlocks, counterweight, roller guide. Okay, ini di bahagian hoistway. Okay, so di bahagian elevator cabs adalah cab finishes, Decorative features in a passenger elevator, including carpet or other flooring, wall panels, door finishes, ceilings, and lighting. Okay. And then under elevator cabs also is the cab control, di mana the controller for the passenger to decide the level, the floor number. Okay. The panel with a faceplate that is mounted in the fixed panel or side wall. And then safety features like phones and door safety edge. Okay. And then the door operator monitors the speed and position of the car doors and compares performance against standard. Deviation in kinetic energy during door travel is corrected within millisecond. This one will control the speed of the door operation, ketika buka, ketika tutup. Okay. And then these are the code compliance for elevators. Basically, for the elevators, we follow the Factory and Machinery Act 1967 under the Electric Passenger and Good Lift. Okay, kita akan untuk elevator basically kita akan comply this type of the act lah. And then the another one is we have to comply the Undang-Undang Malaysia Akta Kilang dan Jentera Pindaan 2006. Okay, dua jenis ni kita kena follow. Okay, maintenance and safety inspection. The top 10 elevator code violation, kebiasaannya yang berlaku. The first is the work added to cab for modernization. Okay, bila kita buat pembaharuan ataupun buat ubah suai ke atas elevator cab tersebut, at the same time we already violate the code. Okay, and then the kinetic energy and force limitation, for example doors. Okay, kita adjust the doors which violate the code. And then the missing door safety retainers, inadequate illumination of cars. Okay, sometimes the maintenance of the lighting in the cab is not well maintained, so will affect to the illumination. And then no self-closing or self-locking doors to machine room. Inadequate lighting in the machine room. Okay, machine room and the elevator cab or elevator cars is the different type machine room di sini lah yang tadi saya cakap tadi apa, ada hose rail, ada hoseway, ada apa, ada switch, ada device, control device, itu di bahagian machine room. Okay, non-comply the elevator car emergency signal. And then no smoke or heat detection in elevator mechanical room. No service fire extinguisher in machine room. Okay, no GFI. GFI ni apa outlets in the machine room and pits. Okay, non-elevator equipment or storage in room. This one is related to the machine room lah. Di bahagian machine room di mana kena ada smoke detector, kena ada fire extinguisher. Okay, perlu dilengkapi dengan safety features lah. This is the example of the missing panel cover in the machine room. And then the trash in elevator pits. Okay, ni bahagian bawah nampak ni buffer jenis apa tu, spring type buffers. Okay, and then in the machine room itself ada banyak barang dijadikan seperti store. Okay, this one is already actually violate the code of the elevators lah. And then because of the maintenance or the inspection, ada liquid yang ditinggalkan. Okay, jadi ruang bahagian ni jadi kotor. Okay, menunjukkan not well maintained lah. Okay, and then the generator nampak lapuk lah. Dia pun sama gak corrosion. Okay, the ceiling also not well maintained. Okay, bahagian ruangan controller, bahagian ruangan machine room tak bersih, berminyak. This one is, I think this one is the hydraulic elevator type. Okay, di bahagian switching. Okay, switching apa silapnya kat sini, kita nampak label dah ada. Okay, mungkin dari segi kekemasan kot. Okay. And then elevator maintenance, apa yang perlu kita ambil tahu ketika buat maintenance untuk elevator. The first one is the evidence of cab modes, counterweight balance. Okay, make sure the counterweight balance can operate well to counterbalance the weight of the cab. Okay, I think the ratio lah, the ratio of the cab weight and also the total passengers lah. And then the evidence of preventive maintenance and logs, FMA compliance issues. Okay, either the Factory Machinery Act is complied or not in terms of safety, age and lighting. And then either elevator can detect the alarm and disconnect during the incident, during the fire incident or emergency incident, for example. And then machine room air conditioning, okay, for example, must have the good ventilation in the machine room machine room. And then the controller, okay, obsolescence and equipment age. Okay, bila dah controller perlu ditukar lah, okay, kalau dah terlalu lama. So recommendation untuk elevator maintenance is, the first one is we have to implement the preventive maintenance program. And the second one is budget for estimated useful life replacement. Okay, untuk yang equipment yang dah tua, dah age, we have to get the budget to do the replacement lah. Okay, for the purpose of modernization or in order to comply the FMA upgrades. Okay. So the elevator maintenance things to look for like this example pictures. Okay, for example lighting, smoke detectors and so on, air conditioning, okay, ventilation system, corroded drive unit. Okay, so this one is related to the apa nama tadi, useful life, estimated useful life replacement, need to do the replacement. And also corroded contact terminal, need to do the replacement. Unevenly worn shift, also need to do the replacement. Okay. And then the elevator modernization project, this one is related to the older buildings that may be renovated and modernized to provide improved performance and service. Again, the service component, controller, hoist machine, door operators may be overhauled and modernized, while visual component, elevator cabs, lobby may be renovated or restored to an original or new appearance. Okay, this one is that really related to the, in order to make the new appearance to the particular elevator lah. Okay, so this one is the operation flowchart. Okay, for the elevator, for example, the right hand side and the left hand side either preparing to move down or move up. Okay, this one, the center one is the moving to floor mechanism, elevator moving and then the stop. Okay, approaching the floor and then the sensor detected and then elevator stop. After the elevator stop, then elevator car door open and elevator stops and then elevator at floor. Then during this time, this is the cycle where the passengers will be exit lah. And then controller check for user input, either ada new passengers or no passengers after that. So if the new passengers, the passenger will be put the input either down request or up request. So this one will be continuously operation cycle. Okay, so this one is the elevator diagram. I think this one is the traction type. So ini ada dia punya counterweight. This one is the apa nama ni, houseway doors. Okay, setiap floor ada dia punya houseway door. Yang bergerak dia adalah dia punya cab. Dalam dekat cab ada satu lapisan door, di bahagian houseway pun ada satu lapisan door. Okay, so di bahagian atas ni control room dia. So macam tadi cakap, control room untuk type of, untuk traction type dia berada di atas lah. So this one is the schematic diagram depending on the application for the building. So actually this one is follow the standard code of the FMA lah, the dimension, but different application, different dimension lah. Okay. And then the lift performance estimation, the assessment of population may be found by allowing between one person per 9.5 meter square. Okay, satu orang akan ambil ruang sehingga 9.5 meter square of floor area, sehingga up to 11.25 meter square of the floor area lah. Untuk seorang akan ambil ruang tu sebanyak tu sehingga 11.25. Okay, so the dua condition sama ada untuk unified ataupun staggered. Okay, for unified starting and finishing time, there is 70% of population per 5 minutes may be used. Okay, but for the staggered starting and finishing time, 12% of the population may be used. Okay, the number of lift will have an effect on the quality of the service. So bilangan lift, makin banyak bilangan lift actually will affect the quality of the service lah. For example, dalam kat sini dia kata ada 4 lift with 80% lift provide the same capacity as 3 lift with 24% lift. Okay, but the waiting time will be about twice as long with the 3 car group. Okay, walaupun kita ada 4 lift dan pengguna dia adalah sebanyak 18 orang, okay, dan kita ada 3 lift, pengguna sebanyak 24 orang, waiting time dia untuk 3 lift dan ramai yang nak guna sama je macam kita gunakan 4 lift tapi 18 orang yang guna. Macam itulah dia punya perumpamaan dia. And then the quality of service may be found from the interval of the group depending on the application lah. For example, for 23 to 35 second is considered as excellent lah. So untuk 35 to 45 second, this one is acceptable for office building. For the hotel and the flat building, 60 second acceptable for hotels and 90 seconds acceptable for flats. Okay, because for the hotel basically the number of floor is higher than the flats lah. Okay, untuk office sebab bilang number of floor untuk office basically lower than the hotel and flats, so that's why the quality of service waiting time is either 35 to 45 second is considered as acceptable. Okay, a method for estimating and comparing efficiency and effectiveness of lift installation is by calculating the round trip time. Okay, this one is the method to estimating the efficiency and the effectiveness of the lift. Okay, kita nak dapatkan efficiency tu melalui the round trip time. An average period of time for one lift car to circulate incorporating statistical data for time lost due to stop. Okay, this is definition of the round trip time lah, and it is measured from the time to lift door begin to open at the main terminal to the time they reopen again when the car complete its cycle. So daripada pintu dia open sehingga dia buka balik. So that one is considered one trip ataupun one cycle. So we take a look the example. Let's say we have a building with 4 floors at 3 meter floor to floor spacing. So daripada satu floor ke floor jaraknya 3 meter, and kita ada 4 floor. And then capacity, the car capacity of 6 person. Okay, capacity untuk elevator car tu adalah seramai 6 orang, dan speed of the travel is 2 meter per second. So probable number of stop, okay, kita follow this equation. So maximum number of stop is S is the maximum number of stop, di mana number of stop is depending on the number of floors here we have 4 floors, so S equal to 4 lah. And then the small capital N here is number of people of the car capacity. So number of people is 6, is already given. So just substitute into this equation, so we get 3.3. So means 3.3 is considered as 3 stops. Okay, 3 stops lah. For probable number of stop, 3 stops. Okay, so kita ada 4 floor, kita akan dapat 3 stop. Maksudnya dia bermula daripada floor yang pertama, lepas tu dia berjalan pergi floor yang kedua, stop yang pertama, pergi ke floor yang ketiga, stop yang kedua, pergi jalan ke floor yang keempat, stop yang ketiga. Macam tu. Upward journey time TU, okay, follow this equation. L is the lift travel, 4 kali 3 lah, 4 floor kalikan dengan 3 meter. The space between one floor to another floor is 3 meter. So the lift need to travel about 12 meter lah. So the car speed is 2 meter per second. So substitute into this equation, then we get the time for the elevator to upward journey is 16.5 second. Okay, bermaksud daripada first floor until to the fourth floor, dia akan ambil sehingga 16.5 second lah. Okay, direct, tanpa berhenti di setiap floor. Sebab dia punya calculation, dia ambil L ni 12 meter, maksudnya ketinggian terus ke 12 meter. Kalau nak dapatkan upward journey time untuk setiap floor, kita ambil L ni sebagai 3 meter lah, setiap floor. Untuk downward, okay, downward L 12 meter jarak untuk keempat-empat floor, and then speed tambah dengan 2 kali speed, so kita dapat 10 second. So downward 10 second, naik 16.5 second. So maksudnya naik lebih cepat, lebih laju, lebih rendah berbanding dengan turun lebih laju lah. And then the passenger transfer time kita allow 2 hingga 3 second untuk seseorang penumpang passenger transfer, depending on the date of the car at 2 second. Okay, so kita ambil 2 second lah. Kita ambil 2 second. Dia allow 2 hingga 3 second, maksimum 3 second lah. So tapi dalam ni, case ni kita ambil 2 second. So 2 kali dengan number of passengers 6, so means 12 second lah. This one is a passenger transfer time. So kita imagine that the first initial condition, elevator cab tu dia ada maximum number of passenger iaitu 6, and then dia keluar masuk passenger yang baru, ambil masa dalam 12 second lah. And then the door opening time, assume door speed is 0.5 millisecond, and the door width is 1.2 meter for example. Then is substitute into this equation, then kita dapat the time for the door opening is 19.2 second, and then the round trip time is the summation of the upward time, downward time, and then the passenger transfer time, and also the door opening time. Okay, so total is 57.7 second. And then another example is estimation of the trade interval and quality of service. For example, we have the office block with 20 stories above a ground floor having a group of 4 lift. Kita ada 4 lift which unified starting and stopping time is to have a floor area above the ground floor x 1000 meter square and floor height of 3 meter. Okay, this one is the floor to floor spacing is about 3 meter. Each car of the lift has a capacity 20%. This one is N, small capital N, and the speed of 2.5 meter per second. This one is V. This one is S. Okay, the clear door width is to be 1.1 meter, and the door are to open at speed of 0.4 meter per second. Estimate the interval and quality of service that is to be provided. We assume that one person per 11 meter square of floor area. So seorang ambil ruang sebanyak 11 meter. So kita ada capacity ground floor dia, the floor dia kita ada 8,000. Okay. Peak demand for 5 minute period. Peak demand untuk 5 minit period adalah boleh mencapai sehingga 124%. And then the car travel depending on the number of floor, the number of passenger multiply with the floor spacing, which is 3 meter, so we get 60 meter. So the car will be travel in maximum 60 meters lah, from 1 floor to 20 floor to floor number 20. And then the probable number of stop, macam soalan yang tadi, equation yang sama. S is the maximum number of stop is 20. And then N dia tak beri kat sini. Okay. Tetapi kita boleh ambil 80% of capacity. Usually approximately 80% of capacity daripada berapa tadi? 20%. 20%. Okay, the car has a capacity of 20%. So kita ambil 16. Jadi probable number of stop adalah 11. Okay. Dah ada 20 story, 20 tingkat, tapi number of stop 11. Okay. Upward journey sama. Okay, lift travel 60 meter and then car speed and then 79 second, and then downward dapat 29 second. And then the door operating time, door speed diberi, door width also given, so 66 second. Okay, the time passenger transport time is we take 2 second for each person, so we have 60% approximately, so 32 second lah. And then the round trip is 206 second. Okay, the capacity of the group, sebab kita ada 4 group, maknanya ada 4 lift dalam satu bangunan tersebut, so kita darablah dengan 4. Okay, capacity of the group is 93% per 5 minute. Okay, divide by 206 is the round trip. Okay, bahagi dengan round trip kali dengan 5. Okay, kali dengan 1 minit 1 jam. 60 ni minit ke jam? Minit kali dengan number of group 4, number of story, and 0.8 is the 80% of the 20% kali dengan 80% of the approximation number of passengers. Okay, so the interval for the group, so setiap group, untuk interval untuk setiap group tu 51.5 second lah. This one bermaksud untuk semua group lah. Okay, so untuk escalator and moving walkways or travelator. Okay, so this time I would like to share with you about the hint for the test. Okay, so listen carefully for the hint test. So basically we have 2 questions for the test, question 1 and question 2. Okay, for the question 1 is the theoretical, so you have to study about the chapter 1 and chapter 2. So I give you more specific for study. So chapter 1 you study about the classification of the building services. For chapter 2 you study about the GBI, okay, Green Building Index. Okay, so that's the first information. For the another information will be another slide lah. So awak kena go through video ni sehingga habis untuk nak dapatkan hint. Kalau tak dapatlah hint. Okay, we continue. Escalators and moving walkways or travelator. Yang ini memang semua orang dah pernah guna, semua orang pun tahu. Escalator, travelator ada di Mydin, mana-mana shopping mall lah. Di Mydin ada benda ni, Mydin ada ni, di Kidmat pun ada ni, okay? Di Ion Mall ada escalator. Okay, so macam mana dia beroperasi dan macam mana design dia, dan what kind of the maintenance that we take a look for the maintenance process, maintenance activities. Okay, so definition of escalator, is the conveyor lah actually. Tapi dia bukannya belt type. Okay. Conveyor type transport device that move people. Basically, escalator is the purpose of the escalator is to move the people. Okay, moving staircase with steps that move up or down using a conveyor belt and tracks, keeping each step horizontal for the passengers. Okay, yang dipanggil conveyor belt ni adalah mekanisme seperti conveyor belt. Tapi dia bukannya guna belt, dia bukan guna belt lah. Okay. And then the escalator, as we know, it was later redesigned by Charles C. Berger in 1897, who created the name escalator from the word scalar, okay, which is Latin for steps, in the word elevator, which had already been invented. Okay, that's the history of the name of the escalator itself lah. And then no invention until up to 100 years ago. And then the escalator has opened up a whole new world as a simple means of connecting different floors. Escalator and moving walk still play a key role in transporting large number of people. Planning escalators and moving walks correctly in shopping centers, trade fair centers, stores, movie theaters, and public transportation facilities is essential for the successful course of business and the smooth flow of the people. Okay, so diambil sebagai escalator ni is one of the technologies that available, okay, in the shopping mall, in the building lah, in zaman sekarang ni. So what is the benefit of the escalators? Have the capacity to move large number of people, and they can be placed in the same physical space as one might install a staircase. Okay, the ability to move a large number of people. No waiting interval like the elevator, except during the very heavy traffic. Okay, they can be used to guide people towards main exit or special exhibits, and maybe weatherproof for outdoor use. Also can be used for outdoor lah maksudnya. So in 2004, it was estimated that US ada 30,000 escalator yang digunakan oleh orang lah, masyarakat, sebanyak 90 billion, okay, 90 billion times in each year. So this to illustrate that escalator is the technology that orang kata apa, bukan crucial tapi demand of the escalator mechanism or escalator technologies in the world. Okay, escalator speeds vary from 90 to 180 feet per minute, and escalator moving 145 per minute can carry more than 10,000 people in an hour. Okay, that's the significance of the escalators actually. So we take a look at the history. Actually, escalator began as an amusement and not for practical transport. But the first patent awarded in 1859 for a steam-generated unit used as an amusement ride in Coney Island. Digunakan dalam amusement, okay, park. Dia belum lagi secara praktikal digunakan di shopping mall dan sebagainya lah. Okay, name escalator by Charles C. Berger macam tadi. Okay, Charles C. Berger sold right to Otis Elevator Company in 1902, which is currently the dominant player in the industry. Maksudnya dicipta oleh Charles C. Berger, tetapi maksudnya macam mana, dicipta oleh Charles C. Berger tetapi dipasarkan ataupun dikomersialiskan oleh Otis Elevator Company. Otis Elevator Company ni yang membawa penggunaan escalator ni ke practical transport lah, to become as a practical transport in any buildings. Okay, The basic operating guideline for escalators regularly, at least monthly, apply a silicone friction reducer. Okay, friction reducer on skirt panels. Ni yang kalau yang sekarang ni kalau kita tak amalkan meletakkan friction reducer ni membuatkan banyak insiden berlaku. Slipper ataupun kasut terselit atau tersekat di bahagian tepi. Okay, banyak insiden yang berlaku sebelum ni kan. Okay, so this one is the guideline how to maintain the escalator operation. So the second one is document any unusual noise or vibration. Okay, setiap noise atau vibration must be take note and documented. Okay, for the next preventive maintenance. Remove any debris. Monitor for broken com teeth. Always remove the startup key from the on direction. Okay. If an escalator or moving walkways make an automatic emergency stop, perform a detailed equipment check before returning to operation. Because when automatically turn to the automatic emergency, so means might be something happen lah to the escalator or the moving walkways. So we cannot orang kata apa? Take to granted lah. Must be detailed equipment check before returning to the normal operation lah. And then do not permit overloading of passengers or freight. Do not permit the use of an inoperative escalator as a stairway. And then the factor affect the escalator design. It depends on the application. And other time the other effect is the factor is physical requirement and the location to be installed, the traffic patterns. Okay, for example, for the huge shopping mall, shopping building. Okay, so we can predict that the number thousand of the people, thousand of the visitor per days. So we can have to we cannot rely to the elevator only, so we have to install the escalator lah. And then the safety considerations, aesthetic preference, foremost physical factors like the vertical and horizontal distance to be spanned must be considered. Okay, so this is the according to the shape. Ada yang jenis curve, ada yang jenis menegak. Okay, this one is the walkways, this one is the escalator step. And then depending on the application and also the physical requirement, so the escalator can be classified according to the arrangement type. The first arrangement type is the interrupted arrangement, one-way traffic. So yang ini relatively inconvenient for the user. For the owner of the department store, it provide the advantage. Untuk user, dia rasa tak convenient. Tapi untuk store department dalam shopping mall, for example, dia ada advantage untuk store department. Sebab apa? Untuk dia nak pergi ke bahagian upward ni, contoh ni upward, untuk downward dia kena melalui kedai-kedai dulu, pusing jauh baru dia boleh turun. Okay, so kita rasa tak convenient, tapi benda ni bagi advantage kepada owner kedai. Okay, untuk parallel interrupted arrangement, this arrangement is used mainly in department stores and public transportation buildings with heavy traffic volume. Okay, untuk heavy traffic volume, dia akan gunakan arrangement jenis yang ni lah. When there are 3 or more escalators or moving walks, it should be possible to reverse the direction of travel depending on the traffic low. Okay, kalau terlalu ramai, mungkin dua-dua side ni dia akan ambil dua-dua direction lah. Crisscross continuous, yang ini biasa kita nampak juga di shopping mall. This type of installation is the one used most frequently as it allows customer to travel quickly. So more convenient for the customers. Okay, to the upper floors without any waiting time. So dia tak perlu nak pusing jauh lah. Okay. And And then the proper inclination, either 30 degree or 35 degree inclination. For the 30 degree inclination, provides the highest travelling comfort and maximum safety for the user. Okay, untuk 35 inclination, the most efficient solution as it requires less space and can be implemented more cost effectively. However, this inclination is perceived as too steep if rise exceed 5 meter, particularly in downward travel. So untuk 30 degree inclination dikatakan travel comfort dan maximum safety sebab dia punya inclination steep dia tu kurang. Tapi kalau 35% dia kata most efficient sebab dia space yang kurang, tapi kelemahan dia even kita exceed 5 meter dia dah rasa terlalu steep lah, terlalu steep, for example particularly in downward travel lah. So this one is the escalator component. As we can see here, the steps and then the truss. Okay, the truss is the structure lah, we call as the truss. And then top machine room, where in the top machine room we have the control panel, drive unit, drive chain, sprocket. So during the maintenance purpose, basically the maintenance operator will do the job this area lah. Okay, untuk bottom machine room, this one is only operating pen, only to apa nama, to catch the step lah, to make sure the step is continuously cycling. Okay, other truss parts is a main thread, trailing track, moving handrail, drive unit and sprocket bottom. Okay, handrail ni yang atas ni, yang kita pegang ni, ni handrail. Okay, so this one another illustration of the escalator component. We have the gear, drive gear, where transmit the apa nama, not the energy, transmit the rotation from electric motor to the drive gear to drive the step, at the same time to drive the handrail. Okay, and then the landing platform and the floor plate. The landing platform, these two platform house the curved section of the tracks as well as the gears and motors that drive the stairs. Ni di bahagian atas lah. The top platform contains the motor assemble and the main drive gear, while the bottom hold the step, return idle sprocket. Dia ada up bahagian up platform and the bottom platform. For the floor plate is provide a place for the passengers to stand before they step into the moving stairs. And then truss is like a structure, okay, the hollow metal structure that bridge the lower and the upper landing. Okay, the lower and the upper landing, okay, support by the concrete lah, steel or concrete support. And the step is the step. Step are solid one piece die cast aluminium or steel, made by aluminium or steel. Okay, handrail yang kita pegang ni, the handrail provide a convenient handhold for passengers. And then the balustrade is the house, okay, ataupun the skirt panel, okay, the skirt panel ataupun the house for the handrail. And then the track is the system to guide the step change. Actually there are two tracks, one for the front wheel and another one is for the back wheels. Okay, safety cautions. Escalator safety is a big concern, especially for children. Okay, each year escalator accident are responsible for numerous trips to the emergency room. These accidents can occur due to loose scarf, short strings or other articles of clothing becoming stuck in the escalator. Little hand and feet have been caught in escalators as well. So, sebenarnya dari segi safety sebenarnya dari segi penyalahgunaan oleh pengguna lah sebenarnya, bukan disebabkan oleh mungkin disebabkan oleh maintenance yang poor, tapi ditambahkan pula dengan cara penggunaan yang tidak betul, so boleh menjadi accident lah. So safety tips should be posted on every escalator and moving walk to prevent these accidents. That's why bila kita pergi ke shopping mall, kita selalu nampak ada notice board ataupun warning precaution untuk kita nak gunakan escalator. Tidak boleh menggunakan stroller, children stroller. Kalau kita ada stroller, kita tak digalakkan gunakan stroller di escalator lah. Okay, so this one is the process of the escalator construction and installation. So this one is the standard dimension which follows the standard. Okay, also still follow the FMA, Factory and Machinery Act. Okay, this one another standard dimension. Escalator capacity, the following formula can be used to ascertain capacity and compare efficiencies and suitability of escalator at building design stage. Okay, di mana N is the number of person moved per hour, and then the L is the length of the step, and then the angle of incline either 30 degree or 35 degree for example. V is the speed of the travel, and P a number of person per step. So an escalator of 30 degree incline, 1 passenger per step, a speed 0.5 meter per second and 400 mm tread or step length. So this is the solution. So this one is the checklist for the maintenance for escalator. Okay, you can read by yourself what kind of the maintenance to be take a look during the maintenance. Okay, right escalator for example, inspect the comb, check the clearance between step and the skirt panel. Okay, look, put the lubricate, step rollers, benda-benda ni semua lah checklist dia. Dan ada dia punya labor hours, berapa lama yang masa yang diambil untuk tujuan costing lah. Okay. Okay, so another hint for the test. Okay, another hint for the test is untuk question yang nombor 1, make sure that you know about the electrical regulation 1994. Okay, peraturan elektrik 1994. You no need to memorize, tak perlu nak hafal. Just make sure that you know how to reach this document from the website. We just I give you hint how to reach this document is by just searching in the Google, type the electrical regulation 1994 and you will get this document from the official website, Suruhanjaya Tenaga official website. Awak boleh dapat dalam tu. Okay, and then one more thing is I want to remind you during the answering the question number 1, especially for the electrical for the regulation questions, make sure that you do not copy and directly copy and paste from the document to your answer. Please make your own words. Okay, saya tak nak awak copy paste. Saya tahu benda ni awak akan dapat secara online. Saya tak nak awak print screen and then awak tepek ke bahagian jawapan awak. Siapa yang buat macam tu, automatically 0 marks for that question. Okay, I remind you. Okay, so moving walkways or travelator, moving sidewalk or travelator is a slow conveyor belt that transport people horizontally up to the practical limitation of about 300 meters. Benda ni biasa kita nampak di airport . Okay, both cases riders can walk or stand. The walkways are often supplied in pairs, one for each direction. Okay, they are particularly useful in large railway and airport terminals, for example, as well shopping complex well and maybe incline up to about 50 degree where level differential occurs. Yang ini application yang kita nampak di Mydin lah contohnya. Okay, dia bukan saja application untuk um, apa nama horizontal application, tetapi boleh incline up to 50 degree. Dia tak boleh lebih dari 50 degree, dia akan lebih too steep. So inclination of 10 degree up to 12 degree are the common international standard for inclined moving walk. Users find that 10 degree inclination provides the most comfortable ride. 12 degree inclination is used whenever the space available is limited. Okay, I think for in Mydin, I think the inclination is about 12 degree. Okay, saya rasa lah 12 degree. Horizontal moving walks can generally be provided for inclination between 0 to up to 6 degree lah untuk horizontal moving. The speed range between 0.6 and 1.3 meter per second, and then the limitation being imposed because of the difficulty in getting off. Okay, combined with walking, the overall space could be about 2.5 meter per second. Material for travelators must be flexible or elastic. Okay, material for travelators must be flexible or elastic and include reinforced rubber for composite. Okay, and then the latter two have the facility to deviate from the conventional straight line. Okay, for the conveyor part, I think we continue for the part 2. So we stop for this part, for part 1. We stop here and then we continue the conveyor, bahagian processing for the conveyor in the part 2. Okay, and then for the next hint for the test will be continue in part 2. Okay, so thank you for part 1. Kita akan continue dengan part 2 nanti.